Exponential and logarithm functions. Exponential functions. Definition. An exponential function is a function of the form y is equals to a times b exponent x, where a is the constant, b is the base, and x is the exponent, where a is not equal to 0, b is greater than 0, and b is not equal to 1, and x is a real number. Our general exponential form is y is equals to a times b exponent x, where b is the base of the function, and changes here will result in, when b is greater than 1, a steep increase in the value of y as x increases, and when b is greater than 0 and b is less than 1, a steep decrease in the value of y as x increases. An exponential function can be in one of the following forms. F of x is equals to b exponent x. F of x is equal to a times b of exponent x. And f of x is equal to a times b exponent cx. F of x is equal to e exponent x. F of x is equal to e exponent kx. And f of x is equal to p multiplied by e exponent kx. Here, b is greater than 0 and b is not equal to 1. And for the exponential function examples, here are some examples of exponential function. F of x is equals to 2 exponent x. F of x is equals to 1/2 of exponent x. F of x is equal to 3 times e exponent 2x. And f of x is equal to 4 times 3 exponent negative 0.5x. So these are example of an exponential function. And exponential function formula. One of the popular exponential functions is f of x, which is equal to e exponent x, where e is Euler's number and e is equal to 2.718. And for the exponential function rules, the rules of exponential function are the same as that of rules of exponents. Here are some rules of exponents. Law of zero exponent, a exponent 0 is equal to 1. Law of product, a exponent m times a exponent n is equal to a exponent m plus n. Law of quotient, a exponent m divided by a exponent n, and it is equal to a exponent m minus n. Law of power of a power, a exponent m open close parenthesis with exponent n, and it is equal to a exponent m times n. Law of power of a product, a times b open close parenthesis with exponent m, and it is equal to a exponent m b exponent m. Law of power of a quotient, a over b open close parenthesis with exponent m is equal to a exponent m divided by b exponent m. And law of negative exponent, a exponent negative m is equal to 1 over a exponent m. Logarithm functions. A logarithm is defined using an exponent. P of x or b exponent x is equal to a. And in terms of logarithm, log of a with base b is equal to x. The right side part of the arrow is read to be logarithm of a to the base b, and it is equal to x. Here, a and b are two positive real numbers. X is a real number. A, which is inside the log, is called the argument, and b, which is at the bottom of the log, it is called the base. So b exponent x is equals to a, which is in terms of log of a with base b, and it is equal to x. And this is a, which is the argument, and b, which is the base, or logarithm of a to the base b is equal to x. Examples of logs. Exponent, 2 exponent 5 is equal to 32, and in terms of logarithm, log of 32 with base 2, and it is equal to 5. 6 exponent 2 is equal to 36. In terms of logarithm, logarithm of 36 to the base 6 is equal to 2, which is the exponent in the given. Exponent, 3 with exponent negative 2 is equal to 1 over 9. Logarithm of 1 over 9 to the base 3. And it is equal to the exponent, which is negative 2. So from exponent to logarithm. Natural logs. Natural logs are nothing but logs with base e. That is, a natural log means log with base e. But it is not usually represented as log of e. Instead, it is represented as ln. Or log of e, it is equal to ln, which is the natural logarithm. So example, e exponent x, which is equal to m, and in terms of log or logarithm, log of m to the base e is equal to x, which is the exponent, and in terms of natural logarithm, ln of m is equal to x. So log of m to the base e is equal to ln of m. Common logs are nothing but logs with base 10. So log of the base 10 is equal to log. If there is no base to a logarithm, it means that the base is always equal to 10. Example, 7 exponent 3 is equal to 343. In terms of logarithm, log of 343 to the base 7, and the value is equal to the exponent, which is 3. 10 exponent 2 is equal to 100. So log of 100 with base 10 is equal to the exponent, which is 2. Rules or properties of logs. Here are the rules, properties of logarithms. Product rule. The logarithm of a product of two numbers is the sum of the logarithms of the individual numbers. So this is a formula. Log of mn, which is product, to the base b is equal to log of m to the base b plus log of n to the base b. Note that the bases of all logs must be the same here. Quotient rule. The logarithm of a quotient of two numbers is the difference between the logarithms of the individual numbers. So log of m over n to the base b is equal to log of m to the base b minus log of n to the base b, where the base value are the same. Power rule. The exponent of the argument of a logarithm can be brought in front of the logarithm. So log of a exponent m to the base b is equal to the exponent m log of a to the base b, and that's power rule. Equality rule. This rule is used while solving the equations involving logarithms. Log of a to the base b is equal to log of c to the base b, and the value is a is equal to c. Thus, the other rules are log of 1 to the base a is equal to 0, log of 1 is equal to 0, and ln of 1 is equal to 0. Log of a to the base a is equal to 1. A with exponent log of x to the base a is equal to x. Log of a exponent m with base b exponent n is equal to the exponent m all over the exponent n. Log of a to the base b. So these are other rules in terms of logarithm. Example. Solve each of the following equations. Number 1. 6 exponent 2x is equal to 6 exponent 1 minus 3x. Number 1. 6 exponent 2x is equal to 6 exponent 1 minus 3x. Based on the exponential properties, b of x is equal to b of y, and x is equal to y. Therefore, 2x is equal to 1 minus 3x. And transpose negative 3x to the left side, or 2x plus 3x is equal to 1. 2x plus 3x is 5x is equal to 1. Divide by 5, cancel out 5, and x is equal to 1 over 5. Therefore, the value of x in number 1 is 1 over 5. And this is the answer. Number 2. 5 exponent 1 minus x is equal to 25. 5 exponent 1 minus x is equal to 25. And 5 1 minus x is equal to 25 is equal to 5 square, or 5 times 5, or 25. So 5 square. With the same base b, means using the formula b of x is equal to b of y, and the value is x is equal to y. The value of b is 5, and x is 1 minus x, and y is 2. Therefore, 1 minus x is equal to 2. Transpose 1 to the right side, or negative x is equal to 2 minus 1. And negative x is equals to 2 minus 1, or 1. And x is equal to negative 1. And x is equal to negative 1. Number 3. 7 exponent 1 minus x is equal to 4 exponent 3x plus 1. 7 exponent 1 minus x is equal to 4 exponent 3x plus 1. The value of b in this case is not equal. Therefore, we will use the common logarithm or the natural logarithm. And based on the example, we will use the natural logarithm for both sides. We will use ln. So ln of 7 exponent 1 minus x is equal to ln of 4 exponent 3x plus 1. Using the logarithm property, log of x exponent r with base b is equal to r log of x base b. Or in terms of ln, r, which is the exponent, 1 minus x, 1 minus x, and multiplied by ln of 7. For ln of 4 exponent 3x plus 1, this is 3x plus 1, open close parenthesis, and ln of 4. Distribute ln of 7 and ln of 4. So ln of 7 times 1, ln of 7, negative x times ln of 7 is negative x ln of 7 is equal to 3x times ln of 4, 3x ln of 4, plus 1 times ln of 4, or plus ln of 4. And transpose all terms to the left side for with x variable. So negative x ln of 7, and transpose 3x ln of 4 to the left side. This is negative 3x ln of 4 is equal to ln of 4, and transpose ln 7 to the right side, or negative ln of 7. And extract x. So x, this is negative ln of 7 minus 3 ln of 4 is equal to ln of 4 minus ln of 7. And x is equal to ln of 4 minus ln of 7, and divide by negative ln of 7 minus 3 ln of 4. And the value for ln of 4, it is 1.386 minus ln of 7, which is equal to 1.945, and divide by negative ln of 7, and it is 1.945 minus 3 ln of 4 is multiplied by 1.386. So x is equal to 0.0916, and this is the value for x. Example number 4. 9 is equals to 10 exponent 4 plus 6x. 9 is equal to 10 with exponent 4 plus 6x. And it's either you will use ln or natural logarithm or the common logarithm. And based on the given, one of the base is 10, so therefore we will use the common logarithm, which is in terms of log. So log of 9 is equal to log of 10 with exponent 4 plus 6x. In terms of logarithm properties, log of 10 with exponent 4 plus 6x with base 10, this is log of b with exponent x, and with base 10 or b, it is equal to x, which means the exponent, which is x, is the value. So log of 9, and using the logarithm properties, log of 10 with exponent 4 plus 6x with base 10, this is equal to 4 plus 6x. So this is the properties. 6x is equal to log of 9 minus transpose 4 to the other side, that's negative 4, and divide by 6, and x cancel out. X is equals to log of 9 minus 4 all over 6. In terms of log, this is the answer, the value for x. Or in terms of the decimal, x is equal to log of 9 is 0.954 minus 4 and divide by 6, or x is equal to negative 0.583, and this is the answer. Number 5. E exponent 7 plus 2x minus 3 is equal to 0. So number 5, e exponent 7 plus 2x is minus 3 is equal to 0. And we will be using the natural logarithm, so both sides with ln, and transpose first negative 3 to the right side, and this is e exponent 7 plus 2x is equal to negative 3 to the other side, or positive 3. And in terms of ln, natural logarithm, ln of e exponent 7 plus 2x is equal to ln of 3. And in terms of ln of e with exponent 7 plus 2x, the value is the exponent, which is 7 plus 2x is equal to ln of 3. In terms of ln of e with exponent f of x is equal to f of x. So ln of e with exponent f of x is equal to f of x. 2x is equal to ln of 3, transpose 7 to the other side, or negative 7, and divide by 2 and cancel out 2, and x is equal to ln of 2 minus 7 and divide by 2, and this is the value in terms of ln, or x is equal to ln of 2 is 1.098 minus 7 and divide by 2, or x is equal to negative 2.95. So you have two options. You can solve the value of x in terms of ln or in terms of decimal points. So x is equal to ln of 2 minus 7 all over 2, or x is equal to negative 2.95. So this is the answer. Example. Solve each of the following equations. Number 1. Log of x squared minus 2x with base 4 is equal to log of 5x minus 12 with base 4. So number 1, log of x squared minus 2x with base 4 is equal to log of 5x minus 12 and with base 4. Logarithm properties. Log of x with base b is equal to log of y with base b, and the equation is x is equal to y. We will have the value for x, which is x squared minus 2x, x squared minus 2x, and in terms of y, it is 5x minus 12. So 5x minus 12 and x squared minus 2x, transpose 5x to the left side, or negative 5x, negative 12 transpose to the left side, or positive 12, and it is equal to 0. X squared minus 2x minus 5x is negative 7x, plus 12 is equal to 0. Using the factoring method, you can have the values for x, or x and x, and it is equal to 0. And the factor of 12 is 3 and 4, and all signs are negative. If you add up, the value is negative 7. So this is 3 and 4, and the sign is negative. So negative 3 times negative 4 is positive 12. And if you add up negative 3x and negative 4x is negative 7x. The value, equate that to 0. So x minus 3 is equal to 0, or x is equal to, transpose negative 3 to the right side, or positive 3, while x minus 4 is equal to 0, x is equal to negative 4 transpose to the right side, or positive 4. Therefore, the values are x is equal to 3 and x is equal to 4. And this is example number 1. Number 2, log of 6x minus log of 4 minus x is equal to log of 3. Log of 6x minus log of 4 minus x is equal to log of 3. In terms of the logarithm properties, we have the quotient rule, which is log of m over n with base b is equal to log of m with base b minus log of n with base b. So using the formula, we can have the log of 6x minus log of 4 minus x and their bases equal to 10. So therefore, we can use the quotient rule. And log of m is 6x and n is 4 minus x with base b or equal to 10. And this will be log of m, which is 6x, all over n, which is 4 minus x. 4 minus x, and the base b is 10, and equate that to log 3. And with the same base b, which is equal to 10, we can have the value in terms of logarithm properties, which is 6x all over 4 minus x, and it is equal to 3. So we have the base 10 and also base 10. 6x is equal to 3, cross multiply 4 minus x times 3, 4 minus x, and simplify. 6x is equals to 3 times 4 or 12. 3 times negative x is 3x, and transpose negative 3 to the right or to the left side. 6x plus 3x is equal to 12. 6x plus 3x is 9x is equal to 12. And divide by 9, and x is equal to, cancel out 9, and 12 over 9, or 4 all over 3. Therefore, the value for x is 4 over 3. And this is the answer in problem number 2. Problem number 3. ln of x plus ln of x plus 3 is equal to ln of 20 minus 5x. ln of x plus ln of x plus 3 is equal to ln of 20 minus 5x, and close parentheses. And using the combined sum of logarithms, which is log of m with base b plus log of n with base b, and the value or the logarithm properties is log of mn with base b. And in terms of ln, that's ln of x plus ln of x plus 3. So this is m and this is n, or ln of x, which is multiplication, times n, x plus 3. And this is the ln, and it is equal to ln of 20 minus 5x. Based on the logarithm properties, which is x times x plus 3 is equal to 20 minus 5x. And simplify, x times x is x squared, x times plus 3 or positive 3x is equal to 20 minus 5x. And transpose 20 and negative x or negative 5x to the left side, or x squared plus 3x minus 5x is positive 5x, and 20 is negative 20, and it is equal to 0. X squared plus 3x plus 5x, or plus 8x minus 20, and it is equal to 0. Using factoring method, you can factor out 20, which is x, and equate that to 0. The factor of 20 is 10 and 2, and it should be, the value is positive 8x. So the value is 10, and the other one is 2, and positive 10x, and this is negative 2. So negative 2x plus 10x is positive 8x, and negative 2 times 10 is negative 20. Using the quadratic equation, x minus 2 is equal to 0, or x is equals to negative 2 transposed to the right side, or positive 2, while x plus 10 is equal to 0, and x is equals to positive 10 transposed to the right side, or negative 10. Therefore, there are two values for x. X is equal to 2, and another x is equals to negative 10. And this is the answer in problem number 3. Example number 4. Log of 25 minus x squared with base 3 is equal to 2. Log of 25 minus x squared with base 3 is equal to 2. Using logarithm property, which is log of b with exponent x and with base b, and it is equal to x. Convert to in terms of log with base 3 using log of b with exponent x with base b, and it is equal to x, where x is equal to 2 and b, which is the base 3, or 2 is equal to log of 3 with base 3 and exponent 2. So this is log of 25 minus x squared with base 3, and it is equal to log of 3 squared with base 3. Using the logarithm properties, you will have with the same value, or base b, the value is 25 minus x squared, and it is equal to 3 squared, or 25 minus x squared is equal to 3 times 3 is 9, and x squared minus x squared is equals to 9. 25 transposed to the right side, or negative 25, and this is x squared, and this is 9 minus 25 is negative 16, and cancel out negative sign, or x squared is equals to 16. X square root of plus minus square root of 16, and x is equal to plus minus 4. So the values of x are x is equal to plus 4 and x is minus 4. Number 5. Log of x plus 1 with base 2 minus log of 2 minus x with base 2 is, and it is equal to 3. So log of x plus 1 with base 2 minus log of 2 minus x with base 2, and it is equal to 3. And we have two terms of log with base 2, and based on the logarithm properties, which is subtraction, and using the quotient rule, log of m over n with base b, which is equal to log of m with base b minus log of n with base b. And this is, in terms of m, is x plus 1, n is 2 minus x, and with base b, or 2. Log of m, which is x plus 1, and divide by log of n, or n, which is 2 minus x with base 2. And close parenthesis, open close parenthesis, and it is equal to 3. Convert 3, the constant 3, to log, which is based on the logarithm properties, which is log of b with exponent x with base b, and it is equal to x, where x is equal to 3, and the base is based on the left side, which is 2, or 3 is equal to log of 2 with exponent 3 and base 2. So log of x plus 1 divided by 2 minus x with base 2, is equal to, in terms of log of 2 cubed and base 2. Using the logarithm properties, we will have the value of x plus 1 all over 2 minus x, and it is equal to 2 cubed. And simplify. X plus 1 all over 2 minus x is equal to 2 times 2 is 4 times 2, and it is equal to 8. And cross multiply. So x plus 1 is equal to 8 times 2 minus x, and simplify. X plus 1 is equal to 8 times 2 is 16. 8 times negative x is negative 8x. And transpose negative 8x to the left side and positive 1 to the right side, or x plus 8x, and 16 plus 1 to negative 1. And this is 9x, and this is 16 minus 1 is 15. And divide by 9, and cancel out 9. X is equals to 15 over 9 is divisible by 3, so 15 over 3 is 5, and 9 over 3 is 3. Therefore, the value of x is 5 over 3 in problem number 5. And this is the answer.